In our previous video, we created a new project and case and imported the surface geometry. In this video, we demonstrate how to obtain a valid volume mesh with the minimum amount of settings. We also demonstrate the importance of feature edges in getting a volume mesh that closely aligns with the underlying geometry domain. Our imported geometry is shown in the viewer. In the Info window, we can investigate the geometry dimensions and other useful information. For the moment, we haven't specified any specific boundary patches. We start our meshing process by specifying the minimum number of required settings. These are available within the master settings group in the settings tree. One needs to select the surface mesh and set the maximum cell size to be used in the meshing process. Our surface mesh is already selected, and we set the maximum cell size to 1. We can see how the chosen cell size compares to the geometry. All input settings that are relevant for the meshing procedure are stored within the meshdict file in our case folder, which file we can also examine from within the application. With the minimum required number of settings defined, we start the meshing process by invoking the Cartesian mesher. The output of the undergoing meshing process is shown in a separate tab. The mesh is created. We first hide the surface geometry. We can now open the volume mesh. We can see that a volume mesh has been created, which, however, doesn't capture well the sharp edges in the domain. Let's fix that. You can remember from our first video that we have removed the feature edges from our imported geometry. We did that deliberately in order to demonstrate to you in this video the importance of this feature for obtaining the proper volume mesh. First, we start fixing the problem at one sharp edge by creating a feature edge. We right-click on the geometry and select the Add to Selection behavior within the Trajectory Selection method of the Feature Edges Selection node and select the edge at the inlet. We add such selected edge to the feature edges, and which now is visible with the geometry. We save the project and start the meshing process again. We can see that the volume mesh now properly captures the feature edge that was added to the surface, while the problem still persists at the remaining sharp edges in the geometry. Now, we will show you how patches can also be useful in capturing the sharp edges in the geometry. By default, the meshing procedure treats the shared edges between two adjacent patches as feature edges, and we will demonstrate that to you now by creating the outlet patch. We create the outlet patch by using the critical angle selection method. We now have two patches in our geometry, outlet and default walls. We save the project and mesh again. We see that the edge at the outlet has been properly captured in the volume mesh. Now that you've seen the importance of feature edges and patches in mesh generation, we can finalize the surface preparation by generating the remaining feature edges and patches for the domain. We then generate the final volume mesh that is fully conformant with the geometry. There is the auto-select method for feature edges selection that helps you generate the feature edges in one go. We use that method. We still need to manually add two circular trajectories at the orifice part. All feature edges are now created. We also define the remaining patches in the domain, inlet and orifice. We rename the default walls into walls. Finally, we change the patch types for inlet and outlet to patch. We save the project and mesh again. You can see that a valid volume mesh has been obtained that correctly captures the sharp edges in the domain. The patches from the geometry have also been transferred to the volume mesh in the meshing procedure. We check the mesh by invoking the CheckMesh utility. We see that the mesh is OK.